Hello, and welcome to the Unified Security Team's Enablement Training. This is the Advanced Malware Protection course. My name is Christopher Hoff. I'm an Advanced Malware Security Engineer in the Northeast for SourceFire. This course is divided into 9 modules. This is Module 1, the Introduction. The other modules will take us through identifying and qualifying opportunities, the competition that you're going to face out in the field, some demonstration techniques, the architecture and design of the solution, which will allow us to set up successful proofs of value. At the end of each of these modules, you'll be asked to take a short 15 to 20 question exam. The goal of this course is to provide you the tools that you need to go into the field and properly position the advanced malware solution. Will give you an understanding of the competitors that you're going to face, as well as the tools to set up both a proper demo as well as a proof of value. So let's jump right into Module 1, the Introduction. In this module, we're going to give you a brief history of malware and the solutions that have tried to deal with the problem. We'll talk about how modern malware works, and then dive right into an introduction to the Advanced Malware Protection platform, which includes Network AMP and Endpoint AMP. The security professional today is having to face an ever-changing landscape. We have increasingly agile actors who are more well-funded, and they're improving their approaches for attacking us. If you think about it, back in the 90s, we talked about malware in terms of its functionality. So a virus was a piece of malware that infected other computers. A worm crawled through your network and spread itself among machines. Trojans were programs that weren't what they seemed to be. Spyware did exactly what the name implies. It watched what we were doing. We were getting phishing emails from guys in Nigeria saying, hey, if you give me $10 today, I'll give you $1,000 in 2 weeks. They were poorly worded, so we could spot them pretty easily. Today, if you think about how much more sophisticated attacks are, people are going to LinkedIn. They're looking up who are the admins, who are the DBAs within an environment, and they're crafting emails to specifically attack that person, with the goal of getting them to click on a link that will download malware onto their computer. Now, what we've done historically in response to this is add many new security solutions to solve these problems, but we're stuck dealing with the complexity. If you think about, a traditional virus as a single point in time event, modern malware relies on multiple technologies to infiltrate your network. And these include taking advantage of a network exploit or targeted spam or again, a compromised web page. Those entry points will place a file on a target system, but that file might not or probably is not the actual malware payload. In the example on the screen is taken from real world, where an unknown file was placed on the system. Now, this was what we refer to as a dropper. This file then downloaded other files that were of unknown disposition. And at some point along the way, one of those files was the actual malware payload. Now, using traditional AV, you may detect the payload itself, but you'll never see the originating file. This lack of visibility leads to reinfection and ultimately more work for the IT team. Our assertion is based on experience that layers of defenses are important, but they aren't foolproof. At the end of the day, companies are investing in security products to protect data. Historically, we've put technologies like firewalls and antivirus as well as VPNs in place to create access policies, essentially building walls around our data. These defensive solutions were augmented by email and web security because, let's face it, we had to start poking holes in those firewalls to give our users access to data. And our email and web security solutions defend against an active attack. These products do their part and can provide much needed context as it relates to a malware outbreak, but they aren't sufficient in battling advanced malware. Now, recently there's been interest in newer approaches like virtual execution or sandboxing, command and control communication detection, and what's referred to as prevalence techniques that do catch more than older approaches, but they still suffer from the same deficiencies as those older approaches. They can be circumvented by a motivated malware writer. As these defensive techniques become more prevalent, the malware writers obviously will adapt and start to evade them. Inevitably, some threat will penetrate the layers of defenses. And then what? How do we see the root cause and quickly remediate the affected systems? How do we bring these individual silos together in order to have a complete picture as far as what's going on a network? That's where FireAMP and the Advanced Malware Protection Platform comes into play. Our Advanced Malware Protection Platform provides visibility on both the network and endpoints to defend against an attack, as well as speed up remediation, find the root cause, and be able to report on that. Some key takeaways that we're going to discuss throughout this course include the automation and big data analytics, which create indicators of compromise, allowing you to see suspicious activity and brings the power of the SourceFire Vulnerability Research Team, or VRT, to the customer. Our retrospective alerting allows us to basically go back in time and block files that we've learned are bad. And our device and file trajectory will give you the lineage and the movement of files within your network. Even with this breadth of protection, we're not a silver bullet. At the end of the day, we want to make sure that we're providing the most accurate contextual information to enhance our defenses before an attack occurs, make intelligent decisions during an attack, and have the visibility into how an attack occurred to remediate after a breach. When we talk about AMP, we're talking about a combination of technologies, which includes the next generation IPS, network AMP, and endpoint AMP, all of which feed into the SourceFire Defense Center. You'll remember from earlier that most modern malware attacks start with an exploit to your network. So you need to be able to see that. They then place the malware onto the endpoint, which spreads across the organization through the network until all the systems are compromised. By creating a complete solution, we're using our big data analytics to provide continuous analysis and allows us to provide rapid remediation from a single pane of glass. As we go through this course, you'll see that we can provide comprehensive control that's frankly unmatched in the industry. So how do we do it? Well, let's start with what we refer to as indicators of compromise. A single event, even a blocked malicious file on an endpoint, doesn't always mean compromise. However, when multiple events, even multiple seemingly benign events, are correlated together, the result can significantly raise the risk that a system is compromised and a breach is imminent or even in progress. The indicator of compromise feature is yet another capability within SourceFire's retrospective security model, leveraging SourceFire's collective security intelligence and big data analytics to deliver prioritized list of potentially compromised devices and quick links to inspect activity and remediate the problem. This goes far beyond what a point-in-time detection technology can deliver by continuing to capture, analyze, and correlate activity after an initial determination is rendered, giving the security professional automated analytics and risk prioritization. Some examples of an indicator of compromise include a file detection, This is actually the lowest ranking basic indicator of compromise. The event indicates that multiple malicious files were operated upon, or in other words, created or moved or executed on the host. We can detect a potential dropper infection. This event is triggered when the same malicious file is created multiple times on the host. This is actually a clear sign that the host is being persistently compromised, and any defensive tools are only treating symptoms and not necessarily the root cause of the infection. Multiple infected files can show up on the same host when the same malicious file is seen being created by different processes. This often indicates the processes running on the system have been compromised. Malware often co-ops clean system processes into doing malicious activity. This is called process injection and is actually a common trait within malware. Digging a little deeper, retrospective security is actually unique to SourceFire and is fundamental in combating advanced malware. This uses our continuous analysis capabilities and big data analytics to aggregate data and events across the extended network for consistent file tracking and analysis. This alerts on and can remediate files initially deemed safe that are now known to be malicious. Should a file have initially passed through or thought to be good or even unknown and is later identified as malicious, the file can be retrospectively identified and the scope of the outbreak understood as well as contained. This ultimately turns back the clock to automatically remediate malware. Prior to this, there had been no way to track files beyond the event horizon, the point of no return, if you will, for tracking files. The moment when the file enters into the network and immediately conceals itself or even embeds itself. With trajectory, customers don't lose sight of malware, making it the only technology of its kind. This trajectory allows us to let customers determine the scope of an outbreak and to be able to track malware or suspicious files across the network at the system level. Previously, it was only available as part of FireAMP. This feature has been extended into SourceFire's advanced malware protection solution on the network as well. Trajectory is analogous to having a network flight recorder for malware, recording everything it does everywhere it goes. Today's malware is dynamic and can enter a network or endpoint through a variety of attack vectors, and once executed on the intended target, typically performs a number of malicious and or seemingly benign activities, including downloading additional malware. As a matter of fact, there's been malware over the years that's been known to download Microsoft patches to protect itself from other pieces of malware. By leveraging the power of big data analytics, SourceFire captures and creates a visual map of these file activities, providing visibility into the entire network, the endpoint, and system level activity. This enables personnel to quickly locate malware, the malware point of entry, propagation, and behavior. This gives us unmatched visibility into the malware activity on the network, ultimately bridging the gap from detections to remediation to control of a malware outbreak. This is a key enabler of retrospective security, which is, again, unique to SourceFire. To put this another way, the existing malware detection technologies such as antivirus or even sandboxing products only look at the file once. If that file is unknown or is just not malware, the file is let through and then forgotten about. It's essentially lost. If we later discover that the file is bad, there's no record of it, which allows infections to spread. Because we're continually monitoring the files, as we'll know where the file is, and even if the file was originally unknown, we'll be able to essentially roll back time and retrospectively block it while alerting the customer to the threat. The solution includes what we refer to as network file trajectory. We've touched on this a little bit, but this allows the security personnel who's struggling to understand the broader impact or context and spread of malware across their network and their endpoints. Is the malware detection an isolated incident, or were multiple systems affected, or were multiple systems involved? File trajectory delivers the ability to track malware across your network using existing source fire sensors or the FireAMP connectors, providing detailed information on point of entry, propagation, protocols used, and which users or endpoints are actually involved. Building on the file-based capabilities within AMP, we're providing device trajectory. This further enhances AMP's capabilities to provide a deeper level of data capture and visualization of malware and file activity at the system level. This delivers critical analysis capabilities for security and incident response teams to conduct root cause analysis and trace the exact relationship between malware and a compromised system and the broader infection that may exist. Device trajectory traces the exact relationship between malware and compromised systems and the broader infections through robust search and filtering capabilities that look for suspicious activity across all systems that have FireAMP installed. They let customers quickly find that suspicious or malicious activity on one system and then very quickly search across all systems for similar indicators. Device trajectory tracks activity and data such as the parent-child lineage and relationship, which files or applications were created by other files, which files downloaded other files, or vice versa. We also look at originating processes, the process that spawned or executed another process. Additionally, we track communications, IP addresses, ports, protocols, and URLs. So if a piece of malware is calling out to the network for instructions or even for other malware, we can relate that information back to the file in question. In addition, having the dynamic trajectory information provides the ability to quickly zero in on a potential indicator of compromise, which are changes and other behaviors indicating compromise has happened and a breach has most likely occurred. With all this information, we can then take an action on the malware. Outbreak control is what you can use to contain and remediate that problem. There are 4 tools that you can work with. The first is what we refer to as simple custom detections, which are based on cryptographic hashes called SHAs. Once you've identified malware you want to block, you can simply use the SHA for the file to create a simple custom detection. You can also just upload the actual file and FireAMP will create the SHA for you. Now, anytime that file is seen in the future, it's quarantined. This is also where cloud recall comes into play. The detection you created blocks it going forward, but cloud recall works the other side of the problem to quarantine the file on any system that may have seen it in the past. This is unique within the solution, because if you think about the way that a traditional antivirus product works, you're asked by the antivirus vendor to find a sample of the file, package that sample up, send it into the vendor's labs, who then have to analyze it, create a signature, QA that signature, and then provide that to you. That can take multiple hours and sometimes even multiple weeks to happen. By being able to just quickly block a potential piece of malware on your system, you're saving valuable time and resources, as well as containing that threat. Now, there may be times when you want to block based on something besides the SHA. Advanced custom signatures are perfect for this. These are like the snort signatures in the next-gen IPS product, so they require some level of sophistication. An example might be after you've used FireAMP's file analysis capability, you discover an entire family of malware that has a common binary. You could write an advanced custom signature to deal with it all at once. FireAMP's application blocking is good for policy enforcement or zero-day protection on the endpoint. You can block an application until it's patched, and release or prevent or you can prevent a group from using specific applications, like maybe somebody in marketing should be using Twitter, but the folks in accounting shouldn't. Whitelisting is mainly a capability to help manage false positives. Simple custom detections won't apply to any files that have been whitelisted. So if you have a custom-built app or a file you know to be safe, the whitelist will ensure that it never gets blocked. It's important to know that products from other companies will tout solutions similar to this, but they won't be able to deal with the remediation in the same way. So the key takeaways here are that this is a unique solution to attackers are determined and they're resourceful. They're well funded and they're able to get malware into our customers' networks. With the velocity of attacks that are happening today and the sophistication of them, point-in-time detections just aren't sufficient. Investment in response is required to be effective. We're delivering a new approach by providing comprehensive and integrated advanced malware protection solution. The retrospective security that integrates prevention and response into essentially a couple clicks give you control to remediate without losing ground. So today we've covered a quick overview of the malware that's out there, the traditional solutions that are trying to deal with it, and how SourceFire or Cisco will deal with the problem and give customers visibility into what's going on their network.